Good day, everyone. So we're back at the harmonic motion here, and I just wanted to talk briefly about the the graph of harmonic motion. So often you'll encounter a graph for harmonic motion, and you'll be asked a couple questions based on the graph, a few pointers and what the on the graph and what it means and stuff like that. So let's dig deep into that. So basically here you've got this value here. This is your initial displacement. That's your x naught. Initial displacement. Now keep in mind this value could be 0, right? So it could start from 0. This graph could start from 0, and that just means that there is no initial displacement. Now the second thing we should know is right here, I'll use different colors. Right here, this is your slope, and what that means, that's basically your velocity. And now this right here, this baby right here, that's your amplitude, and you're going to read it off from this y-axis here. Basically, that's going to be your amplitude. You remember we've talked about this amplitude before. We've said that what the amplitude stands for. And now the period is basically, and you will definitely need this. The period is from the trough to trough. So that's your period. And that's equal to 2 pi over omega n. Okay. And now let's talk about this here is your maximum velocity. That's where your maximum velocity occurs. Okay, and alrighty, so let's see here. This baby here, this right here, that's your phase angle. That's represented by phi over omega n. Alrighty, sweet. Okay, so, and like we said, this is your initial. That's going to be your initial velocity. And mind you, this could be 0 as well. Okay, so now I'm going to talk about, really quickly, I'm going to talk about some key pointers here. Let's switch to blue. It's a better color. Key points, basically. So let's say the harmonic motion equation is x of t is equal to a cosine omega nt plus or minus whatever, minus phi, depending on the okay, so let's talk about this negative sign here. So the negative sign, you should know what this negative or positive sign means. So this guy here, what this means, negative means that the shift is towards, the shift in graph is towards the left, to the right, sorry, right. That's basically in the direction of the positive x-axis. And positive means the shift in the graph is towards the left. It's funny, hey? Yeah, that's how it works. So if we go back here, this graph, it's a cosine. So if it's it's actually a sine graph. So this sine graph has been shifted to the left, so it's got to be a positive. However, if you can look at it in another way, you could say this is a cosine graph, but it basically shifted to the right, because a cosine graph starts from here, right? So if you shift it to the right, it basically that's your phase right there. That's your phase. Okay, so let's move on. Okay, so let's say, for example, you're asked to find the maximum velocity. So maximum velocity is basically when so if you derive the equation and you put x naught t, you're definitely going to end up with a omega n a sine omega n t minus phi. Okay. So when is sine maximum, right? So this value here should be equal to 1. That's when you have maximum velocity. So I'm going to say Vm, which is Vmax, is equal to omega Na. That's this value, because it's going to be multiplied by 1, so that's it. And now they might ask you for the maximum acceleration. So you do the double dot thing, and then you get negative omega n squared a cosine. So in order for this guy to be maximum, your cosine, it's got to be this value here has got to be a 0. So that's when you get cosine equal to 1. Hence, your A max is when you've got this value right here. So that's done. That's out of the way. So these are really important key pointers that you should know and keep in mind. And we've already talked about how to find the phi, the phase angle. So that shouldn't be a trouble. Is there anything else you need to know? Let's look here. Yeah. The other thing you should need to know is, like I said, we've already talked about these angles before, but these variables before. But let's point them out again. So that's your natural frequency. That's your natural angular frequency, and then you've got all of this also can be expressed in terms of period. That's your period, right? And what else do we? And then, yeah, and period also can be expressed as a function of frequency. Remember, the units for this is radians per second. The frequency here is in hertz. So they're both frequencies, but that one is, the units are different for both, for each one. All right. Now, what else do we need to talk about? Yeah. Let's go back here. Like I've said, this is an expression for maximum acceleration. That's also, you can also use that to find your acceleration at different points. in the motion, in the harmonic motion, and this too could be used to find the velocity at different points in the harmonic motion. And that's about it. Thank you very much. See you next time.